we're going to give the Python workshop today, which is kindly presented by May, a PhD candidate in our department. So previously, May has offered a previous Python workshop before, and we received a lot of positive feedbacks from the audience. So this is why we invite her back and give us another workshop on the extended topic. So let's welcome May, and I think we can get started.
Thank you very much, Yinan, for your introduction, and thank you everyone for joining, and good afternoon. Today, we are going to talk about how to do the data analytics pipeline effectively in Python. And I will use the US real estate market data in order as a use case to show you how you can apply the functions that I introduced. So I'm going to give you a category of what you can do with Pandas and what Pandas is in general. And then we will use Pandas functionalities to follow the data analysis pipeline, starting with reading the data, reformatting it, and cleaning the data, handling the missing values inside it, manipulating and aggregating, and finally visualizing the data and the distilled information from it, basically, with using various plot types, including plotting over the maps and also bar chart races. So data has become an integral part of our current world. It helps us to make better decisions and predict future. Pandas is an open source Python data analysis library. The name is derived from the term panel data. And it is a term in econometrics, which refers to multidimensional structured data sets. Although nowadays hierarchical indexing has become a more common replacement of adding additional dimensions. Pandas allows to easily deal with tabular data like spreadsheets. And within Pandas, you can easily and flexibly work with this type of data. And Panda is one of the most sought after libraries for Python and one of the most widely used data science libraries in the world. First of all, as you already know, a lot of these functions for data analysis can also be done inside Excel files. But why do we need Pandas for? Microsoft Excel can only handle a limited number of rows of data without freezing and crashing. So when we want to work on million rows of the data, we need to think of a better solution like Pandas. And in addition to being much faster, Pandas support subsequent machine learning tasks better. And it is kind of and has an ecosystem of libraries that supports it for different kind of statistical and learning problems. And Pandas also automates the cleaning of the data so that we do not need to repeatedly do the same kind of task, but we can use the automatic methods and function inside Pandas for that. And also, we usually use Excel nowadays for storing the data if it is not too much of it. We don't have too many rows, and we read it inside Pandas, so they are kind of complementary. DataFrame is simply a table of data with records of the data in the rows and columns. Pandas has two main data structures. One is series, which is one-dimensional data, and another is DataFrame, which is two-dimensional table of the data. And it is the most used because and the data frame is not unique to Python. It is also available in Java and R, and you get the very same kind of functionalities in other languages too. And it is generally the most commonly used one because of its ease of use. And it is also another property of DataFrame is that it is size mutable, meaning that you can append or delete rows and columns. So like any other classes of any other object in an object-oriented kind of programming, DataFrame as an object has attributes and methods. So these 10 are all the attributes of the data frame. And when you want to, and the attributes are the essential information inside of the data frame that are pre-computed and readily available. You simply fetch the attributes by calling the name of the attribute on the data frame. Let's say this is the data frame that we have with 5 rows and these columns. You can use dot columns, dot d types, or dot shapes like this to fetch these attributes. And instead of transforming the variables or data, they are used to give you more information about the data and what it is already inside of the data. But there are more than that in Pandas. The main thing that is that you can transform the data or you can inspect the data for different purposes. So let's see what are the main methods that you can use with Pandas. So firstly, you can use methods to view and inspect the data. So I want to give you the methods in categories so that you have a better understanding and you can remember it easier. So for viewing and inspecting the data, these are the main methods that are used. And you can see right away that we use parentheses after the name of the methods. This is in contrast with the attributes. For attributes, we don't use parentheses because the attributes are not taking any parameters. But these methods can take different parameters to customize for your need. For example, head and tail. Head is for returning the first n rows of the data. The default is the first 5 rows of the data, but you can specify any different number. And tail is to return the n last rows of the data. Info is to give you a concise summary of the data frame. So with info, you get to know what are the columns, what are the types of the columns, how many data points are populated in the records for each of the columns. And we will get to see that on the examples, but I just want to give you a bigger picture first. And then for describe is going to generate the descriptive statistics on the quantitative columns. And then the value counts is going to return a series of counts of the unique row values. So the general use is to specify a specific column, for example, date, and then see what are the unique dates inside of the data frame. Next, what you can do with a data frame inside of Pandas is to handle the missing values. First of all, you need to know if there is any missing value and how many of them there is, or which columns have missing value. In order to do that, you can use isNA or isNull. Both of them do the same thing. They are going to return a Boolean of the same size object that indicates in each of the values, it indicates if it is a missing value or not. And generally, the other methods are applied over the result, the output of isNA. Methods like any or sum, are commonly applied over the output to give a summary of if there has been any missing value in a specific column or how many of them there is. Another thing, once you know that about the existence of the missing values, you want to deal with it. You either want to drop them or you want to fill them. So drop NA is to remove the missing values, and it also takes parameters to customize for your need, if how you want to, which ones you want to drop and how you want to drop, so that you can specify very in details if, for example, there is more than 2 missing values in a row, you want to drop it, but if it is only 1 missing value, you don't want to drop, something like that. And another thing is fill NA is to fill missing values using specified values or methods. For example, you can specify a value of average of the column to be filled in the missing value, or you can say, for example, if it is a time series, you can use a method to use the value before or after, things like that. And next is data cleaning. Data cleaning is to, first thing you can use is to rename the columns, for example, to make a better sense and be more sensible. So this is how you do it. You use the rename method and specify a dictionary of how you want to map the current names with the new names. Another thing you want to do, you want to sort the values so that they are going to give you a better picture and in more order. You can sort by a specific column, or you can sort by rows, and these are all the parameters that you can specify. So dropping specific columns that are not useful to your analysis is another cleaning task that you need to do, because you don't want to have a crowded data frame or use a lot of memory when you are only going to work on a specific columns. Another thing is, as type, is very important to specify data types correctly, because when you are reading the data frame, like for example from CSV files, there are the numbers are read as just objects or strings. You cannot perform operations on them, or you cannot calculate on them. So you need to specify their type to be able to do that. Similarly, this is specific for the date columns. So in order to be able to extract the different components of the date, like month, day, and year, you need to convert it into the date type object using this method. So you also want to, after having cleaned, after taking care of the missing values and everything, you want to finally manipulate the data. You want to filter out and group the data, use the pivot tables, and see how the information adds up and aggregate. So these are the methods that you use for that. So apply is, you can apply, we will see examples of that. You can apply any function that you write, customized function on your data frame, specific columns of your data frame. And so to make it easier for you, I want to go to this for group by, because this gives you a better picture. So the group by function can be used as a first step in the exploratory data analysis, and you can use it. So like as you can see, you can group by one column and then aggregate the values inside each of the groups. Like here, we are grouping by the color, and inside each unique color, we are taking the mean of the values inside the cells. This is how Groupby works. It gives you aggregated results of the data. And pivot table, similarly to the pivot table in the Excel files, it is a convenient way to gain a different perspective into the data. You can reorganize the columns and rows in a different way for your purpose. And these, so another thing is that when you want to locate a specific value inside of your table, you use ilog when you know the address of it, when you know the index of the column and rows, you will use ilog, but most probably we don't know the index. So what we do, we use conditional log. We write a condition of the what we want inside of log method, like so, to filter out the rows of the data that we want. So for example, here we are specifying, we want to filter out the data frame where shield is bigger than 6. When shield is bigger than 6, we have the Boolean of true, and we are going to get that specific row where shield is bigger than 6, and we are going to throw the rest out. So I'm going to give you an example of the Realtor.com dataset, which is this dataset I downloaded from Realtor.com, and I have uploaded it into Kaggle for being able to analysis and share notebook, Python notebooks, Jupyter notebooks on that. And this data has median and average list price for from 2016 to 2021. It has the median listing price per square foot, and it has the median days on market, total active listing, etc. So let me stop the share here and move to and give you the link to the data set, and we can work on the code together if you want, or you can check it out later. So can you see the data set page?
Yes, we can see that.
Okay, so this is the link to the data set. This is public data set that I have shared into Kaggle. So if you go to the codes tab, you see there are two codes. I'm going to majorly work on this code. You can, excuse me. So let me also share this one. So what you can do, you can edit this code, copy and edit this code and work together with me, or you can just check and see how it works now, and later on you can work on this code for yourself. So once you open up the code in the editing mode, you see something like this. So it is a kind of, this is a Jupyter notebook. Jupyter notebook is also very popular for creating a report, because with Jupyter notebook you can have documentations, you can have your code and your result and visualization all together. As you can see, I have also added a picture here. So it is very ideal for making a report. especially for data analytics. So here I have explained that this is the kernel in which I have processed the data set, which is divided at the state level. So I have the data set at the different levels. I have it at the state level, zip code level, and county level. So over here, we are analyzing it at the state level. So this is a convention to first, in your notebook, you first import all the libraries that you are going to need for a cleaner look, and you are all ready to go once you do that. I'm not using very fancy libraries. It's the general things like NumPy for linear algebra, Pandas that we are all mainly talking about, and some of these libraries that I have imported, like Seaborn, GeoPandas, Matplotlib. These are for visualization, and these are kind of inside of the Pandas ecosystem. They work along with Pandas very well, and with the data frames. So these are the things that I have imported. Another thing is this bar chart race library, using which I want to create a bar chart race, which has become very popular. So over here you can see that we want to load the data set, and this is the directory of the data set that we are looping over and printing all the different files inside of it. So the main files that we are interested in are these three. So these are all the historical trend data, and one of them is at the zip code level, one of them is at the state level, another is at the county level, and this is the one that I am interested in. So when I want to open the data, I simply copy this line and use it inside of here, this method read CSV, which is a method of Pandas to opening CSV files. You can, using Pandas, you can open many different formats of data, and this is one of the capabilities of Pandas, to be able to work with different formats. But before going to the data set itself, I want to show you that what is inside Pandas library and also DataFrame. So if you check the directory of Pandas, you see there are 142. The length of the directory is 142, and these are most of the things over here. You see, these are the methods of Pandas. You see, these are different file formats that you can read with Pandas. All different things, starting with read. So this is starting here. So this read CSV is what we are using because we are opening a CSV file, but there are plenty of different formats that you can open here. And also, so I have created, so you can create a data frame in different ways. You can read it from another spreadsheet like a CSV or Excel file, or you can create it right away inside of Python, like here. I have created an empty data frame using pd.dataframe. And once you see what's inside of it, you can see a list of many methods that are inside of this. There is 543 different methods or items inside of this directory. So then I want to, because I was confused before, I want to give you a heads up that some of these methods are shared between Pandas and DataFrame. So if you check what are the shared ones, you get this list. This is so for example, is NA and is null that we discussed before can be used both as a pandas method and a DataFrame method using this like this. So you can write pd.isNA and give it a data frame, or you can apply it over the data frame, not giving it anything. So these are two ways giving this exact same result. So don't be confused by the shared ones. There are these are a few. There are only few of them, like is NA, is null, melt, merge, and pivot tables, things like this. So the reason for having the shared ones is to be able to stack the different components of the analysis together, or to have a compact or these are only different styles of writing and are going to function the same way. So now let's go to see what we have inside of the data set. But before that, let me know if there is any question and if I am going too fast. Okay, so hopefully we are on the same page. So here I have loaded the data set, the state history data set, using the address that I had printed and using the method read CSV of the pandas. So once I have read it, it is going to be a data frame. A data frame, like we discussed, has kind of different kinds of attributes and methods. So this shape is an attribute. So you can print the shape of the data frame. The shape of 0, the first value inside of the shape is the number of rows, and the second value in the shape is the number of columns. So here our data set has 3,112 records and 39 columns. And this is df.head is a method that we are applying over the data frame. And this is by default showing us the first 5 rows of the data, but you can simply change it to any other values, like showing only 2 rows of the data. And then so as you can see, just changing the parameter inside of the method, you can customize it to your purpose. Another attribute of the data frame was d-types. Once you apply or call d-types over the data frame, you get a list, this list of all the columns and their d-type or data type. So this is the data type and the columns. Let me run this file again to make it the most updated version. So these two, the info and describe, we also discussed. These are to see the data more to gain more information of the data. And so over here you can see a state is an object, while we know that there are only a specific number of states. We can make it a categorical variable. So what I'm doing is I am using as type method to make it a categorical variable, as type category. Then once I use info, you can see that the state has now become a categorical variable. once while it was an object. Object is just a general data type because object can have numbers and strings and different things inside of it. It can be a mix of things. But once you specify what the data type is, you are going to have a better memory usage, and you are going to it is making it for a cleaner application. And so another thing that I have categorized before, this method is described, is going to give you a descriptive statistics of only the columns that are quantitative. So for example, you don't see a state in these columns. You only see the columns that are quantitative, and their descriptive statistics are listed here, like a mean, a standard deviation, and different percentiles, maximum, and things like that. So another thing, as I mentioned, is to correct the data format. You want to make it a date time type so that you can extract from it different components of it. So first of all, I'm using PD.to date time over the specific column of date, which is here named month date. This is not making much sense. For that reason, after reformatting it using this format, I have observed the format from the data itself. So I see that the year and month is reported. So I'm going to adjust this format based on the data that I have. And then reformatting it to the date time, I'm also renaming the column to a more sensible name like date. And always when you want to keep the changes, you need to use in place equal to true to overwrite the data frame with the new one. If you don't do that, the changes would be only to temporary. It's not going to overwrite. So now that we have a date type kind of column for date, we can extract from it month, year, and date. Since it is date time, and we don't have the time information, we are only keeping the date part because the rest is not useful to us. So we have replaced this date with this formatted date column, and we have added month of inside of the date in a new column, and year of the inside of the date in another column called year. Now we can sort the values. Sorting the values can be by different columns. I want to sort by the state and date. And by default, the sorting is going to be ascending, but you can make it, if you set the ascending to false, then you can have a descending. So you can see, since I have sorted in an ascending way both the state and date columns, you can see the states start with A and end with W, and the date starts with 2016 and end with 2021. So this is now sorted. So another thing that we can do, we can group or we can filter different or classify different rows together. Right here, over here, I am I'm creating a new column called category, which is going to give me some information about the record based on the conditions that I have set. For example, I want to know if this record has shown an increase in price compared to the previous year or compared with the previous month. Fortunately, I have this information in as a column in my data frame already. You could easily calculate it yourself, having had the average listing price, you can find the differences, monthly differences or yearly differences, but these are already calculated. So what I want to do, I want to have 3 categories of the records. If the record has shown no increase in price compared to the last year, I want to give it a first category. If it has shown decrease from the past month, I want to give it the second category, make it second category. And if it has shown increase in listing price, it is the third category. So these are my filters or my categories. So using NP, which is short for NumPy, NP.select, as I mentioned before, these NumPy and Pandas work very closely together. You can use them together. So that's another good point about Pandas. So so NP.select takes these filters and the values for the filters. So the values are down from last year or down from last month based on the definition of the filters. And the default is what it is not covered by the filter. So the default is that there has been an increase in price unless there has been a decrease. So when I calculate that over the data frame, I add the new column of category, then I can use the value count to find out how much the percentage of the prices has shown an increase and how much has shown a decrease over the last year or month. So doing that, you can see that there has been 73% of price increase from all the records from 2016 to 2021. So the records start from fall of 2016 and end with, so we are in the middle of 2021. So it ends October 2021. So in that period of time, we see most of the months and most of the estates, most of the estate months have shown increase in price, 73% of that. But once we narrow it down to only 2020 or only 2021, we see even more inflation of the price. So we see around 76 increase in price for 2020 records and around 80 for 2021. So this is a huge inflation in the market, which is not backed by the fundamentals of the market, like the job market, because job market has been down comparably. So that's why we can say that probably the market is inflated. And but it is also, to be fair, the data for 2021 is only for the first half of the year, which is usually the prices go up for the spring and summer, and it's probably kind of the increased percentage might be explained with that. So now let's go to see visualize some of the market trends. So first thing I want to show you is kind of the monthly price, the thing that I just said. We can see it in the data too. Usually the first half of the year show an increase in price. You can see that these so the April, May, and June are the peak for every year mostly, and then we have a decline over the winter. And So to be able to visualize a plot like that, what you need to do, you need to group by the date and take the average of the price. So I want to, because it is already monthly records, you want to group by the date, and this is the group by, and then you filter out, you only want one column because you are only showing this column, average listing price, and take the mean of that. And then once you, this is the same line here, the exact same line. Once you plot it using bar chart, you get the result. And there are some kind of formatting for a cleaner formatting and more beautiful formats that you can see here. These are only for visualization, which is very important because we need to make it as clean and nice as possible. So what I have done, so you set the labels, that's easy. You can write text over the plot for some more insight. For example, I have added these 2 lines of text over the figure. So this is going to give more information. And also I have made the spines or the borders of the plot invisible. And I have created a grid because I have made the borders invisible. I want to connect the values to the data in some way. So this is for the grid. So these are the formatting things. For example, this line, I have made it kind of bolder over here just to make it more beautiful. Or the color map, you can see. I have defined it. I have defined the color map inside of the plot, and the color map is, it has the same a list of colors, the same color, and then I have changed 3 of the colors to another one so that I get this effect of having 3 columns popping out different, have different color. So another thing we can do, we can see that which states have at least 1 month of decrease in price in 2020 compared to 2019. So to do that, if we want to list the states that have shown a decrease, so we already have the category variable, so that's easy. We have already created a new column named category, which shows if there has been a price has gone down compared to that last year. So all we need to do, we need to locate the specific year that we are interested in and take out the estate, the name of the estate, and we want to type the unique values because it can happen. So one estate can have gone lower in price different dates of the 2020. We want to only type it once. So this is why we are using the unique method. And the same thing for 2021. So we can see that these are the different states that, like the DC, Hawaii, Texas, Washington, these have shown at least once decrease in price from the last year. So this is another plot. So for this one, I am using Seaborn. Seaborn is another kind of plot for used with which is very well integrated with Pandas. So it takes the data frame as the data, makes it very convenient. So the data is the data frame itself, and then we can plot different columns as X and Y. So X is the each of the bars, the values on the X axis, and average listing price is what we want to make the bar for. Since we are short in time, I want to quickly show you an application of apply function. So although these are all simple methods, you can use it in many different ways. You can make it as complex as you want, combining things together. So this is one way I have used apply here to be able, the reason, the function of this here is to type the name of the states over the map. So to do that, I'm using the annotate method inside of the apply. So this is a function defined inside of the apply method, and the function itself takes another method for annotation. So you can chain these together or just use them together to give you the result that you want. And this is GPD is GeoPandas. GeoPandas is the library for that includes geographic information to plot the data over the map. Over here, I want to plot my data over the US map. Using the color map, it shows you like what has been the price or averaged over the time, the period that we have. So this shows the price average from 2016 to 2021. And I have excluded Alaska and Hawaii to fit the screen better. So you can plot different columns over the map. So for example, here is the state housing total listing comparison. So you can see Florida has had the most number of listings because it is the darkest. And Texas follows it, California and New York and Georgia. So to do that, you need to use, first of all, you need to so this GDF is what you need to first create. You need to first have the merged, you need to have the geographic information inside of your data frame, or if you don't have, you need to join it with that information. So what I'm doing here, I have my data frame, I'm joining it with USA coordination data set in another data frame I have opened from here. So this has all the state shape information. I'm joining this together, and then after having the joined, I have all the columns necessary to plot my data set over the map. Then you give this to the GeoData frame library to plot it for you over the map. So I want to finish with this bar chart race. So bar chart races have become very popular recently, although they are not as informative, but they are eye-catching and they can attract a lot of attention. So sometimes they are going to give you the attention to your result that you want. So let me. So you can see, starting from 2016, going to 2021, we are comparing the average price, housing price of different states and how they have competed kind of against each other. We are using bar chart race library to create that. You can change the how fast or how slow it is, the quality of the bar chart race, and the colors. Things can be customized. So this is just as easy as just this line, one line of code. Once you have the data frame cleaned and created. So since we are running out of time, let me finish here, and just let me know if you have questions. You can also leave a comment for this notebook in Kaggle, and I will answer your question there too.